Welcome. This is Cambridge AS and A Level Probability and Statistics 1, May-June 2020, paper 51. The score when two fair dice are thrown is the sum of the two numbers of upper faces. Show that the probability of getting a 4. How can I get a 4? So I can get either 1, 3, 2, 2 or 3, 1. This is the way how can I get 3. So this is 1 upon 6 times 1 upon 6, which is 1 upon 36. Again 1 upon 6 times 1 upon 6, which is 1 upon 36. And 1 upon 6 times 1 upon 6, which is again 1 upon 36. So total will be 3 times 1 upon 36, which is probability of x equals to 4, which is 1 upon 12. Two dice are thrown repeatedly until it is a score of 4. So this is called to be geometric progression, geometric distribution. This is geometric distribution. In geometric distribution, mean is called expected value of x, which is 1 upon p. That is a formula you need to remember, 1 upon 12. So which is going to be 12. Find the probability that the score of 4 is obtained in the sixth throw. So what is this? 5 throws. 5 throws, you should not be getting 4, and the sixth throw you should be getting 4. So not getting 4 is 11 upon 12, 5 times, and lastly sixth time I should be getting 1 upon 12. So then I simplify this one, so I should be getting 0.0517. Now probability of x is less than 8 means probability of x equals to 1 plus probability of x equals to 2 plus and so on till probability of x equals to 7. So what am I going to do this one? For this, it is going to be 1 minus probability of x greater than or equals to 8. X greater than or equals to 8. So for this one, 1 minus p whole to the power of 7. So which is 1 minus 1 upon 12 whole to the power of 7, which is 1 minus 11 upon 12 whole to the power of 7. Simplify 1 minus 0.513, which is 0.487. So once again, probability of x greater than 8 means less than 8 means from 1 to 7. 1 to 7 means you should be subtracting from sum of all probabilities will be 1. So you should be subtracting from 1 greater than or equals to 8. Greater than or equals to 8 means less than 8, you should be subtracting it out. So 1 minus p whole to the power of 7. Then you should be getting that answer. Question number 2. Find the number of different arrangements that can be made from the 9-letter word jewelry in which all E's are together. All the E's are together, jewelry. So let us write L-L-E-R-Y. All the E's are together, 1, 2, 3. So 9 minus 3, which is 6 units. 6 units. Then, and 2 L's are together. So what am I going to do? This, rather than doing like this, I cut over here, write it down, all the E's are together. So E, E and E, and all the L's are together, L, L. So remaining will be nothing but what? J, W, R, Y. So totally how many units are there? 6 units are there. 6 units can be arranged in 6 factorial ways. Times those 3 E's again can be arranged among themselves in 3 factorial. These 2 L's can be arranged among themselves in 2 factorial, but they are being identical by 3 factorial by 2 factorial. So my final answer is going to be 6 factorial, which is 720. Find the number of different arrangements that can be made from the 9-letter word in which 2 L's are not next to each other. So first of all, I'll find total number of ways, which is 9 factorial by 3 factorial, 2 factorial. 3 factorial is because for E's and 2 factorial is because of L's, which is going to be 30,240. Now L's together. If L's together are there, what is this? 9 minus 2 is nothing but what? 7 units plus those 2 L's together. So which will become 8 units. 8 factorial divided by, this is 1 unit. 8 factorial divided by 3 factorial, which is going to be 6720. So L's not together. L's not together will be 30,240 minus 6,720, which is 23,520. Question number 3. A company produces small boxes of sweets that contains 5 jellies and 3 chocolates. Gmail chooses 3 sweets at random from a box. Draw a probability distribution table. So we are drawing a probability distribution table for number of jellies being drawn. How many jellies are there? 5 jellies, but we are drawing only 3. So it can be 0 jelly, 1 jelly, 2 jelly, or 3 jelly. This is X. Probability of capital X equals to small x. Now, first one is probability of 0 jelly. 0 jelly means the first one is a chocolate, and the second one is also chocolate, and the third one is also chocolate, which becomes 1 upon 56. Then, what is that? 1 jelly. First one is a jelly, second one is a chocolate, and third one is a chocolate, but times 3. Don't forget, it can be happening in not times 3. So therefore, this answer is 15 upon 36. 15 upon 36. Then, instead of doing 2 jellies, I will be doing it, or I can do 2 jellies also. So 5 upon 8 and 4 upon 7 times 3 upon 6. Again, don't forget to do times 3. So this is going to be 30 upon 56. 30 upon 56. And finally, it's going to be 3 jellies. So 5 upon 8 times 4 upon 7 times 3 upon 6, which is 10 upon 56. So this is 10 upon 56. Now, that is the probability distribution table. The company also produces large boxes of sweets. For any large box, the probability it contains more jellies and chocolates is 0.64. So P equals to 0.64. So Q will be 0.36. 10 large boxes are chosen, N equals to 10. Find the probability that no more than 10. No more than 10 means x minus x equals to 8 minus x equals to 9 minus x equals to 10. No more than 7 means 8, 9, 10 has to be subtracted. 1 minus 10C8, 0.64 whole to the power of 8, 0.36 whole square. 10C9, 0.64 whole to the power of 9, 0.36 whole to the power of 1. 10C10, 0.64 whole to the power of 10, 0.36 whole to the power of 0. So 1 minus 0.164156 minus 0.064852 minus 0.11529. Simplify that, 0.759. Question number 4. In a music company, there are 8 pianists, 4 guitarists, 6 violinists. 7 of these two are to be selected. Totally, how many I have to select it out? 7. How many different selections can be done if there are at least 2 pianists, at least 1 guitarist, and more violinists than guitarist? More violinists. So minimum 2 should be there. Then more violinists than guitarist. So if this is 3, then this should be 2. Maximum I'm trying it out. Total it should become 7. Then I keep 2 over here. Then I make it as 4, 1. Then next time I make it as 3. Maximum violinist is 3, 1. Then again 4, 2, 1. That's all. These are only going to be the ways. So for this one, what should be the answer? 8C2 times 4C2 times 6C3. Then 8C2 times 4C1 times 6C4. 8C3 times 4C1 times 6C3. 8C4 times 4C1 times 6C2. These values are 3,360, 1,680, 4,480, and 4,200. Add them all, 13,720. Question number 5. On Mondays, Rani cooks her evening meal. She has a pizza, burger, or a curry with the probabilities of 0.35, 0.44, and 0.21. So, pizza, burger, and curry. 0.35, 0.44, 0.21. When she cooks the pizza, Rani has some fruit, the probability is 0.3. So for that fruit is yes, 0.3. No fruit will be 0.7. When she cooks burger, she has a fruit, the probability is 0.8. Yes and no. This is 0.8, so this has to be 0.2. When she cooks curry, she never has any fruit at all. So yes, no, 0 and 1. Draw fully tree diagram we have done. Find the probability that she has some fruit. What she has some fruit? She can have pizza and a fruit, or burger and a fruit, or from this one it is 0. So this is going to be 0.457. So what is it? Pizza and fruit, burger and fruit, curry and fruit. That's going to be the answer. Find the probability that does not have a burger given that she does not have any fruit. So does not have any fruit given that she does not have any fruit. Whatever is after given that, that should go to the denominator. Does not have any fruit. Have a fruit, just now we got yes 0.457. So 1 minus 0.457. And the numerator is nothing but what? She does not have burger. So probability of does not have burger, does not have fruit. Does not have burger, does not have fruit is nothing but what? She can have and pizza and no fruit. Pizza and no fruit, and curry and no fruit. So it's going to be 0.35 times 0.7 plus 0.21 times 1, which is going to be 0.455 divided by 0.543, which is going to be 0.838. Next, question number 6. The length of female snakes of a particular species is normally distributed with a mean 54 centimeters and standard deviation 6.1 centimeters. Find the probability that a female snake has length between 50 and 60. So lies between. Whenever it is lies between, what am I going to do? Second one minus first one. So probability of x less than 60 minus probability of x less than 50. So probability of x less than 60 minus 54 divided by 6.1 minus probability of, this is z less than 50 minus 54 by 6.1. So probability of z less than 0.9836 minus probability of z less than minus 0.6557. So it is probability of z less than 0.9836 minus 1 minus probability of z less than 0.6557. So this value is going to be 0.8375 minus 1 plus 0.7441, which is going to be 0.582. So now to the next part, part B. The length of male snakes is normal distribution. The random sample of 200 male snakes, 32 have less than 45. So probability of x less than 45 equals to 32 upon 200. So probability of z less than 45 minus mu by sigma equals to nothing but what? 0.16. Now 0.16 is not there in the table. So what should I be doing it out? Probability of z less than mu minus 45 by sigma equals to 0.84. 0.84 from the table should be equals to 0.994. Now for the next one, it is greater than 56 centimeters is 17 upon 200. So less than 56 will be nothing but what? Remaining 183 upon 200. So probability of z less than 56 minus mu by sigma equals to 0.915, which is 56 minus mu by sigma equals to 1.372. Now divide both. Mu minus 45 by sigma divided by 56 minus mu by sigma equals to 0.994 by 1.372. then we can see that sigma and sigma gets cancels. So mu minus 45 upon 56 minus mu equals to 0.994 divided by 1.372. 0.994 divided by 1.372 should be giving me 0.724489. So from here, solve it out. You should be getting the value of mu. Directly, I'm writing that answer. You should be getting the value of mu as 49.6. Substitute this value of mu over here. You should be getting 49.6 minus 45 divided by sigma equals to 0.994. Sigma equals to 49.6 minus 45 divided by 0.994, which is 4.65. Coming to question number 7, draw the histogram. For drawing the histogram, we need to do the frequency density. Frequency density is 18 divided by 10, which is going to be 1.8. 24 divided by 5, which is 4.8. 30 divided by 15, which is 2. 20 divided by 20, which is 1. And 8 divided by 10, which is 0.8. Then draw the x-axis and y-axis. This is frequency density, and this is going to be the heights in what is that units? Heights, number of bars sold, number of days. So number of days is the height is going to be the days. Number of chocolate bars sold. Number of chocolate bars sold. So it is up to 60. So 10, 20, 30, 40, 50 and 60. And the height maximum is 4.8. So 1, 2, 3, 4, 5. Now it is 1 to 10 is 1.8. 1.8 is 1 to 10. Then 11 to 15 is 4.8. 4.8, 11 to 15. Then, but basically we have seen that between 10 to 11 there is a gap. So what am I supposed to do it is make this as 10.5 and this is 0.5. Similarly, this becomes 10.5 and 15.5. So this becomes 15.5, 30.5, 30.5, 50.5. So you should make it continuous. 50.5, 60.5. So from 0.5 to 10.5. So we erase this, and from 0.5, so 0.5 till 10.5 it is 0.8. 10.5 it is 0.8. See, we can see that it is 10.5. Then 10.5 to 15.5 it is 1. 10.5 to 15.5 is 4.8. So this one was not, so 1.8 till 1.8, and 10.5 to 15.5 is 4.8. 4.8 till go till 4.8, 15.5. So 15.5. Then 15.5 to 30.5 is 2. It is till 2 till 30.5. Then 30.5 to 50.5 is 1. 30.5 to 50.5 is 1. Then 50.5 to 60.5 is 0.8. What is the greatest possible value of the interquartile range? So Q1. Q1 is nothing but what total, how many people are there? There are 100 people, 100 days. 100 divided by 4, which is 25. 25th one. 25th one comes in 11 to 15. 11 to 15. Q3, 100 times 3 upon 4, which is 75. 75 comes in. Do the cumulative frequency. This is 18, 42, 72, 92. So 75 comes in 32, 31 to 50. 31 to 50. So what is the difference? Maximum difference is from 50 minus 11, which is going to be 39. Calculate the estimate the means and standard deviations of the chocolate bars sold. So for mean, it's going to be 18 times 5.5 plus 24 times 13 plus 30 times 23 plus 20 times 40.5 plus 8 times 55.5 divided by 100, which is 2355 divided by 100, which is 23.6. For variance, it is 18 times 5.5 square. So I copy this entire thing. This entire thing, I can copy that over here. I copy this entire thing over here. And do the squares. 5.23 square, 23 square, 40 point square minus mean square. Mean is nothing but how much? 23.6 whole square. Simplify that, you should be getting 224.57. So what will be the standard deviation? Square root of 224.57, which is 15.0. That's going to be the answer. That completes this paper. See you in the next paper. Bye.